Try again.
Yes, so in this video we're looking at the O-Level 2020 mock examination paper that was written this year. So this is the paper you wrote as your mock examination at Respiration Study Center. So we're looking at the combined science paper 1, and this paper is it's a 1 hour paper. And here's some few instructions here. You were asked not to open the booklet until you were told to do so. You were to read instructions, and then you were to answer 40 questions. And from the 40 questions, you're choosing from option A, B, C, and D. And you just choose one you consider the most correct, and you record the choice in soft pencil. And you notice that there is another instruction that is saying, or just some additional information that is saying, each correct answer will score 1 mark, and there won't be any mark which will be deducted for a wrong answer. So those are just the brief instructions there. All right, so okay, let's look at number 1 here. So number 1 is saying, which of the following is not a raw material for photosynthesis? So you notice that here we're saying which one is not. So carbon dioxide is actually a raw material for photosynthesis. The same applies with water. These are raw materials of photosynthesis. Oxygen is not a raw material for photosynthesis, and light, it is actually used in photosynthesis. So this makes our answer option C here, because it is the one which is not used as a raw material. In actual instance, oxygen is actually a product of photosynthesis. This is actually a product. It is not a raw material. The second question here, name the cell shown below. Maybe to avoid distractions, let's just zoom in so that we just focus on one part of this here. So you're asked to name the cell below. So this is actually the root hair cell. The root hair cell is characterized by a sort of like a hammer shape. It's sort of like a hammer where you have the nucleus here and the vacuole here. So the option A is saying this is the palisade cell. No, the palisade cell, you know, it's sort of like a rectangular. It's in a more or less like a rectangular shape, something like this. This is a palisade cell, and the organelles will be in here. And then we have the sperm cell. The sperm cell, say it looks like more or less like a tadpole. And then we have the red blood cell. I've been giving you an example of that coffee drop. Like it's a biconcave, it's a disc, biconcave disc shape rather. So here we're going to choose answer option D, because this is the root hair cell here. Let's look at number 4. Which statement about diffusion of water is not correct? Again, take note of the word not correct. We want the one which is not correct. So diffusion of water takes place only in liquids. Only in liquids. This is so much conclusive. Diffusion of water is actually osmosis, as I mentioned the other day. It's actually osmosis. This is osmosis, because we define osmosis as the diffusion of water molecules or the movement of water molecules. So it's actually a type of diffusion, but in essence, it's water which is actually diffusing in that scenario. So it's not going to take place only in liquids. So this cannot be correct. And then diffusion of water relies on random movement of molecule. Yes, it's because they are highly concentrated on the other side, and they have a low concentration on the other side. So they are going to randomly move to the other side there. So we have C here, water molecules are small enough to diffuse through the cell membrane. Yes, the cell membrane is actually permeable, and it can actually permit water molecules to pass through it. And then the other option is water molecules are small enough to diffuse through the cell wall. Yes, the cell wall is actually passively permeable. It can allow anything to pass through. So our option here, which is not correct, is A. A is not correct. Diffusion of water takes place only in liquids. Diffusion of water can take place in cells, it can take place in tissues or anything of those sort. Okay, let's look at the next question here. looking at number 5. So it's saying that digestion of starch starts in the, does it start in the stomach? No, the stomach actually has a low pH and amylase cannot act in the stomach. Yes, it actually starts in the mouth. It cannot start in the ileum, not duodenum as well. Let's look at number 6. Diagram below shows section of a mammalian heart. So this is a section of a mammalian heart. So since we're just doing a little bit of revision, we'll just look at 1 or 2 parts here before we dig into the question, because the question is just a narrow question which is just asking us to identify eggs. But you might be asked to identify this vessel here, which we call the vena cava. And then here we have the your left is your right, so this is the right atrium. And then here we have the bicuspid valve. Remember, so this is the tricuspid valve. And here we have the tricuspid valve. Remember the saying I once told you, you try before you buy. So we have the tricuspid valve first before the bicuspid valve. So this is the tricuspid valve here. And then we have the left ventricle wall here. And then the blood goes through here and it goes to the lungs. And to the lungs, it gets through what we call the pulmonary artery. So this is the only artery which actually carries deoxygenated blood. Because remember, this blood doesn't have any oxygen. And it is coming from the rest of the body and it does not have any oxygen. So it needs to collect some oxygen. So it is pumped by the left ventricle so that it pumps oxygen it pumps blood rather to collect some oxygen here. So it collects some oxygen here. And after it collects some oxygen, it gets right through the pulmonary vein. And then from the pulmonary vein, it gets through the bicuspid valve and then straight through the semilunar valve. And then it goes out using this vessel here called the aorta. So that's basically a summary of the heart. I hope you took note of that. So in this question, you are asked to identify structure X. So structure X, this is the ventricle wall. This here is the ventricle wall, and specifically it is the left ventricle wall. Remember, your right is the left. So this is the left ventricle wall. So is it the atrium wall? No, this is not atrium wall. The atrium wall, these two here, this one and this one are the atrium walls. It's not the tricuspid valve, but it is the ventricle wall. It is not the septum muscle. The septum muscle is this muscle here which divides the heart. Sorry. The septum muscle is actually this muscle here which divides the heart. This is the septum muscle. So yeah, we're choosing answer option C there. Let's look at number 7. What is the purpose of respiration? So respiration, is it to enrich the atmosphere with oxygen? It's not the primary purpose of respiration. Respiration is there to release some energy for the organism, like what answer option B is suggesting here. So I think we would pick this one as the best answer. Let's just see the other options. To supply water for the organism. No, it's not going to supply water for the organism. The organism is actually going to get its water from the soil, not from respiration. To take oxygen into the lungs, no, this is not respiration here. Maybe you might get confused with respiration and breathing. Breathing is now the process of taking in air. You want to take in air into the lungs, but now after that you have gases exchange as well. After gases exchange, and then the gases in specific, the oxygen gets into the bloodstream, and then it is used up during the process of cell respiration. And in this process, energy is released. So we're going to take answer option B here, to release energy for the organism. But number 8, it's saying COVID-19 is caused by, it's not a bacterium, it is not a protozoa. Yes, it is a virus. Like this has been said over and over and over and over again in this year 2020. It has been a difficult year for everyone, And we all know about this COVID-19, and it's actually a viral infection. So COVID-19 is caused by a virus. Let's look at number 9. So I'm switching here. Okay, we have Aliyah dropped some food onto her book with white pages. So the book developed a white spot. So it's developing a white spot. So which food substance is likely to be in this food? So it's supposed to be here a permanent white spot. It's supposed to be a permanent white spot, because it can be a white spot which can fade away or something like that. But this is a permanent spot. A permanent spot. This affects. We have what we call the spot test. The spot test, which actually tests for FERT. Okay, let's move on to number 10. Which statement describes an adaptation of the red blood cell in relation to their function? So we want the statement which is going to describe an adaptation of the red blood cell, which is actually related to its functions. So we have answer option A, which is saying the red pigment hemoglobin to give them color. So this doesn't have anything to do with its function. The presence of nucleus, from the word go, presence, nucleus. The nucleus is actually absent. So we're going to eliminate these two answers here. We don't have a nucleus in the red blood cell. And then answer option C here, you have the biconcave disc shape gives it speed to move through through tissue. Yes, this might be correct, because it has a shape which makes it flexible to move through cell and tissue. And then they are able to mature and die. This is not an adaptation, and it is not even related to its function. So we're going to take answer option C here. So by eliminating answers, you can see that by using the method of elimination, you can see that you can take out all the answers which are not even close to being correct by using elimination, and you'll be left with the most suitable answer. And it actually comes out from the rest. So let's look at number 11. Where does most of the oxygen enter the blood? So where does most of the oxygen enter the blood? So here you have it like the alveolus. Yes, in the alveolus, these are the air sacs, and this is where gaseous exchange is going to happen. Gaseous exchange doesn't occur in the bronchioles, not in the bronchus, not in the trachea as well. So that's the alveolus. Number 12, what happens to most of the energy as it flows through an ecosystem? So is the energy recycled? The energy is not recycled, but energy is actually lost in the form of heat. Most of the energy is lost in the form of heat. That's why you see that from one trophic level to the other trophic level, you have energy being transferred from one trophic level to the other. But in the process, some energy is lost in the form of heat there. Right? Which structure stores sperms? So we want a structure which stores sperms. Now, the testes, they produce sperms. The scrotum is actually a bag which holds the testes. The penis is actually the organ which passes out the semen or the sperm. So we want to take answer option C here. This is the epididymis, and it is the one which actually temporarily stores sperm in males. Right, let's look at the other question, number 14 here. So we're going to the top. Yeah, okay, we have the female reproductive system here. This is the side view. So you have one is the fallopian tube. 2, this is the uterus, of course, where it's directed from the fallopian tube, you get into the uterus here. And 3, this is actually the cervix here. And then down here you have the vagina. So where do fertilization and implantation occur? So fertilization is going to occur in the fallopian tube, or what we call the oviduct here. And then implantation, it happens in the uterus. So we have 1 and 2 is our option there. this option. So an oxpecker bird perches on the back of a buffalo while the buffalo feeds on grass. The bird is ticks that feed on the blood of the buffalo. So these ticks, they're actually feeding on the buffalo. So which food chain represents these feeding relationships? You have it like grass, buffalo, you have oxpecker and the tick. The buffalo is feeding on the grass, the oxpecker feeding on the buffalo, and this is not correct here. The buffalo is feeding on the grass, the tick is feeding on the buffalo, and then the oxpecker is feeding on the tick, and this is a correct option. Any option which doesn't start with grass is incorrect because we always start with the primary producers. Right, let's look at number 16. Which statement about sexual reproduction is always correct? So it involves one parent. It doesn't involve one parent. It actually involves two parents. It involves the fusion of nuclei. Yes, this is always correct. It produces genetically identical. They are not going to be genetically identical. They are going to be not identical. So it takes place only in animals. Sexual reproduction is also we say sexual reproduction also takes place in plants. So this cannot be an option here. So we're going to answer option B here. Let's look at the next question, number 17. So we are now in the chemistry section here, number 17 here. So 1 dm cubed is equivalent to 1,000 cubic centimeters here. Right, here you have the atomic mass of oxygen is 16. That of magnesium is 24. Find the empirical formula of an oxide of magnesium with this much of oxygen and this much of magnesium. So you're calculating the empirical formula. So you have Mg here, and then you have oxygen here. So with Mg, you're using 0.96 here. And then you have 0.32 here. So what you're going to do, you're going to divide by their masses, the 24 here and the 16 here. So I'm going to divide by 24, which is the mass for magnesium, and here I divide by 16, which is actually the mass for oxygen. I pull out my calculator. Let me create. So I want to divide 0.96. This is divided by 24 here. So I'm going to get 0.04. I have 0.04 here. And then I divide 0.32 divided by 16. So let me clear here. So I have 0.32 divided by 16 here. So I'm going to get, this is 0.02. 0.02. Right, so I have 0.02, I have 0.04. So I divide by the smallest. So if I divide by the smallest here I divide by 0.02, and here I divide by 0.02. So for magnesium, we find that I will get 2, and then for oxygen, I'll get 1. So this means you have Mg2O. So I'm going to pick answer option A here. Okay, number 19. An isotope does not have the same number of electrons. An isotope has the same number of electrons, so this cannot be a correct answer. The same number of protons, it actually has the same number of protons since it has the same number of electrons, because the electrons and the protons are equal in terms of their numbers when it is neutral, when it is a neutral atom. Okay, and then they have the same chemical symbol. Yes, they have the same chemical symbol, but they do not have the same nuclear number. Since they do not have the same nuclear number, it now means, or it now implies, that they do not have the same number of neutrons as well. So they don't have the same number of neutrons, they don't have the same nuclear number. But isotopes, they have the same number of electrons, they have the same number of protons, they have the same chemical symbol. You take an example of carbon 14 and carbon 12. Carbon 14 has 14 as this nucleon number, carbon 12 has 12 as this nucleon number, so they're different nucleon numbers there. But carbon 14 has 8 neutrons and carbon 12 has 6 neutrons, so the neutrons are also different. But with the protons are 6 for carbon 14, the protons are 6 for carbon 12. The electrons are also 6 for carbon 14 and the electrons are also 6 for carbon 12. And the symbol is C for carbon 14, the symbol is C for carbon 12. So those are the same, but only the nuclear number and the number of neutrons are different when it comes to isotopes. So number 20 here, consider the reaction below. Fe2O3 plus 3 carbon monoxides, and then we get 2 iron and 3 carbon dioxide. So the reducing agent is, right, carbon monoxide should be the reducing agent because it is the one which is taking oxygen from iron 3 oxide. So carbon monoxide is actually the reagent. If you want to dig too much in the reaction, you notice that this iron 3 oxide, it is actually reduced. So here we have reduction. So it is reduced, we have reduction, it is reduced to iron. So itself becomes the oxidizing agent because it is giving oxygen to carbon monoxide. So carbon monoxide has been given oxygen, so it is oxidized, and it is oxidized to carbon dioxide here. Right, number 21, a liquid with differing densities can be best separated with, we cannot best separate it with distillation. Like you want to consider maybe liquids with different densities like oil and water. Those are liquids with different densities. Like you notice that the oil will float on top of the water. So you want to use decanting. Decanting is actually the best method for separating those. With chromatography, you're separating dyes and the likes. With winnowing, you're separating solids with different densities, not liquids with different densities. So with winnowing, you're separating solids, but they have different densities. With fractional distillation, you are separating liquids that have different boiling points. Right, number 22, you have 450 degrees Celsius, 1 atmosphere, vanadium 5 oxide are conditions needed when making. So these are the conditions we need during the contact process. These conditions, we're going to use them to make sulfur trioxide. Let's go on to number 23. So you have sulfuric acid, sodium hydroxide forms. Sulfuric acid and sodium hydroxide are going to form a salt and water. This is an acid-base reaction. Okay, and then during electrolysis of acidified water, oxygen forms at the positive electrode because oxygen is negatively charged. So it is going to form at the positive electrode, which we call the anode. This is the anode. And then number 25 is saying a hydrocarbon has, so a hydrocarbon, it actually has carbon and hydrogen only. So we're going to pick C here. It's saying here an organic compound has the name ethanoic acid. So eth meaning we have 2 carbons here. Oic meaning it's a carboxylic acid. So to which series does it belong to, and how many carbon atoms does it have? So it doesn't have 3 carbon atoms. It is not an alkane. It is not an alcohol. It is a carboxylic acid and it has 2 carbons. So we're picking answer option D here. We're picking answer option D here. Let's move on to number 27. It's saying the internal diameter of a test tube can be best measured using a vernier calipers. We are going to use the vernier calipers. We cannot use a micrometer screw gauge. This one is best for maybe thin wires when you want to measure the diameter of a thin wire. We cannot use a ruler. You're not going to measure anything accurately there. You're not going to use a tape measure as well. Right, number 28, momentum is the product of mass and velocity. It is the product of mass and velocity. The product of mass and velocity is momentum. So let's look at the next question here. We have number 20. It's also a calculation. You have an effort of 150 newtons raises a load of 600 newtons through a distance 2 meters. The effort moves a distance of 10 meters. So you want to calculate the efficiency. So to find the efficiency, you're going to find the mechanical advantage first. So the mechanical advantage is load over effort. So I'm going to divide the load divided by the effort. So I have 600 divided by 150. You should get something like a 4 there. Sorry, you have 600 divided by 150. Yes, you should get a 4. You have a 4 there. So the mechanical advantage is 4. And then you want to find the velocity ratio. So you say the distance moved by the effort divided by the distance moved by the load. So this is 5. So you have 4 over 5. So why are we doing this? So for you to find the efficiency, you're going to divide the mechanical advantage. So you say MA over VR. You say MA over VR and you multiply by 100. So this is MA over VR and then you multiply by 100 so that you get the percentage here. So we're going to say 4 divided by 5. So divide this answer by 5. And then I get 0.8. Then I multiply it by 100 so that I get 80%. So the efficiency of this machine is 80%ish, which is quite a lot for a machine in general. So dark surfaces are they good absorbers of heat? Yes, they're actually good absorbers of heat. Let's circle this answer is possibly the correct one. Poor emitters, they are not poor emitters. They are poor, they're good reflectors of heat, fast at moving heat. So they are good absorbers of heat. I think this is the best answer that we can pick here. Number 31, a unit for resistance is the ohm. So we're going to choose B here as the option. And then number 22, the diagram shows the 4-stroke of a petrol engine. So which diagram? A, B, C, and D is the inlet stroke. So we want the inlet stroke. So with A here, you have all the valves closed and you have the piston moving up. Since the piston is moving up and all the valves are closed, this is supposed to be the compression stroke. So we're going to label C here. Such as the compression stroke. But with B, you have the inlet valve open and the piston is moving downwards here. So this is actually the inlet stroke. It's possibly the intake stroke. So let's label I here. And then we have C. C, you have the spark plug with a spark and all the valves are closed and the piston is moving down. So this is possibly the power stroke here. So let me label P here. And then we have option D. We have option D. We have the piston moving up and then the exhaust valve opened. So this is possibly the exhaust stroke. So let's label E here. So we want the inlet stroke. The inlet stroke is answer option B here. Number 33, a wind blows with a force of 200 newtons against a wall of height 2 meters and length 5 meters. So you want to calculate the pressure. So pressure is force divided by area. So what is the area first? Because we actually have the force already. We have the force as 200 newtons. So the area you calculate it by saying the height multiplied by the length. So you have 2 by 5 and then you have 10. So you're going to say 200 divided by 10 and then you get 20 Newton per meter squared. That is the option there. Okay, let's look at number 34. Number 34, a DC motor converts, it is going to convert electrical energy to mechanical energy, not mechanical to electrical. This is a generator, not light to electrical, and not electrical to sound. Of course, sound is there, but we want to pick answer option B here because it's mechanical energy. There's a kinetic energy when the DC motor starts to run by moving or rotating or something like that. The core of an electromagnet is made from iron. It is not made from steel. It is not made from copper. It's not made from zinc. In the diagram below, resistor A is 3 ohms, B is 2 ohms, and C is 2 ohms as well. So you're asked to find the total resistance. So you have 2 resistors that are in parallel. So with parallel resistors, you know the formula 1 over R1 plus 1 over R2, because you have 2 resistors here. And then this you say to the power what? To the power -1. This to the power -1. So this is the formula for finding the resistance for resistors that are in parallel. If you have more than 2 resistors, you're going to just add 1 over R1 plus 1 over R2 plus 1 over R3, 1 over R, whatever the number of resistors that you have. And all that you say to the power -1, or the reciprocal of that, in essence. And then you add this to the one that is in series. So you add this to 2. So we're going to say here, so it's 1 over 3 plus 1 over 2. So let me open a bracket here. And I'm going to say 1 over 2. I add it to 1 over 3. And then this to the power what? Or I close the bracket first, and then this to the power -1. So to the power -1 here. And then this is going to be added to 2. So this is my answer here. This is 3.2 ohms. So I have 3.2 ohms as my option. So I'm picking answer option A here. Number 37. What is the current if a component is rated 2,400 watts and 240 volts? So remember, power is equal to voltage times current. So we have P is equals to VI. And if you want to find I, you're going to divide both sides by V. So you have power divided by voltage is equal to current. So you're dividing 2,400 divided by 240, and you're supposed to get to 10 amps here as your answer option. Right, let's look at number 38. We're about to finish. So in this case, you're given statements and you are asked which statements are correct. You should actually read the statements carefully. A guided media transmitter converts information into an electrical current through a wire or cable to a receiver. Yes, this should be correct. An unguided media transmitter uses electric current to produce radio waves. Yes, this could be correct. But now we have radio waves are transmitted through a wire to an antenna. So we have radio waves transmitted through a wire. This is the bad part here. Radio waves being transmitted through a wire. Radio waves are transmitted through the air. So 1 and 2 only are actually correct in this case. Right, number 39 is asking 3 types of signal transmitters are optic fiber cable, antenna, and antenna is not a signal transmitter. Optic fiber cable, coaxial cable, shifted pair cable. Yes, this is actually these are actually signal transmitters. We have optic fiber cable, antenna, and antenna is not. And here we also have antenna. So answer option B is the correct one here. Let's go with number 40 here. Electricity costs 10 cents per kilowatt hour. This 10 cents per kilowatt hour. Now you are asked how much does it cost to run a 0.75 kilowatt machine for 20 hours. So you want to convert these kilowatts to kilowatt hours. So you want to multiply 0.75 by 20. I think you should get a 15 or something. Let's see. You have 0.75 multiplied by 20. So that you get the kilowatt hours that this machine is going to use. So we have 15 kilowatt hour, of which for every 1 kilowatt hour, the electricity is going to cost you 10 cents. So you are going to say 15 multiplied by 10 cents. you're going to say 15 multiplied by 10 cents, and then you get 150 cents. So with 150 cents, you have $1.50 there. So it's $1.50. That's the amount that you're going to spend, or that's the cost of electricity for running this machine for 20 hours. Okay, so that's it for this video, and if you enjoyed watching this video, make sure you subscribe to our YouTube channel and share this video to your friends, especially those who are writing this December. And yes, catch you next time. Bye bye.